All right, here's a rundown of the notes on compound machines. So when two or more simple machines are used together, it's called a compound machine. To calculate AMA, it's pretty easy because it's the old one we've used, AMA free, which is force resistance over force effort. So all you'd have to do on a crazy machine like this to find its AMA would be have a force meter here to tell how much force you're applying when you pull on this rope, and have a force meter here that measures how much resistance it's giving. So not too hard. But IMA is a little harder to calculate. So IMA for multiple machines, the IMA total, if you have more than one machine, you have to do your IMA of the first machine times your IMA of the second machine. So if you remember, normal formula was I'm a deer, but if you have multiple machines, you want your DE on machine 1 divided by your DR on machine 1. And then times your DE on machine 2 times DR on machine 2. And then you keep that going. As many machines as you have, you're just doing DE over DR until you're done with the machine. So this could be however many machines you have is how many DE over DRs you got to multiply together. All right, so here's a pretty basic example. So in this thing, we have two machines going on. They're not super easy to see. One's kind of tricky, though. We have one machine here, which is actually a wheel and axle. It's hard to see the wheel and axle, but if you imagine this thing spinning around and around and faster and faster and faster, you can kind of start to see that big wheel, right? And inside is our little axle. So even though it doesn't look like that, pretend this is spinning super fast around and around, and you'll see that wheel and axle. Second thing you have is here, and this is a gear train. So I have two separate machines, and your total IMA will be to take the DE over DR for your wheel and axle times, now instead of DE over DR in a gear train, we use gear ratio, which we just spent time learning about gear ratios. That's either Nout over Nin, Tout over Tin, all that stuff. Okay, so all I have to do is figure out DE, DR, and gear ratio to get this total. So over here, my DE, so IMA total. This is a little sneaky. I put a trick question in here. DE is not hard. You're like, oh, my effort would be here. I'd pull down on this crank, which is an 8-inch distance. Then on DR, most people want to say 4, but 4 is a trap because, remember how I said, imagine this thing spinning around and around and around? The 8 inches is a radius. What's the 4 inches? The 4 inches is diameter of your resistance. So you actually only want the radius. If you did a radius for your effort, you have to do a radius for your resistance. So on here, you'd actually use 2 inches. And that was kind of a trap. You either have to do diameter and diameter or radius and radius. So I kind of tried to trick you there just to make sure you pay attention. When you're doing wheel and axles, you got to know if you have radius or diameters. Now, gear ratio we just did. In this case, it's Nout over Nin. Right, because we have number of teeth in this problem. So number of teeth out is 36 teeth. Number of teeth on the input would be 20 teeth. Because I crank down here, this becomes the input of your gear train. Teeth cancel, inches cancel, and IMA total is going to be, I don't know, what's that? 4 times that, 7.2. All right, no units there because they all cancel off. Sweet. Now, here's a good question to remember. See if you remember efficiency. Efficiency is AMA over IMA times 100. So I have my IMA up here. All I need to do is find my AMA. So off to the side, I'm going to say am free. FR over FE. So my FR is 100 pounds, and my effort is 15 pounds. And that divides to make 6.6 repeating. So really my efficiency is going to be 6.6 repeating over 7.2 times 100. And you will get, make sure you don't round, right? When you do 6.6 repeating, just fill that screen, just go crazy. Divided by 7.2, and you get 92.6% efficient. Alright, good blast from the past, right? Okay, now to a more difficult thing. Alright, so we got a crazy Rube Goldberg thing, right? You pull down on this pulley. I would call this my first machine. Right? It pulls on a string that turns this wheel, which turns this axle. So you have a wheel and axle as your second machine. So it pulls up on there, rotates this down. It wraps this string around, which pulls down on a lever. There's my third machine. So I like to go through and label in order what machines are being pulled. Then we have another pulley. That's my fourth machine. So when this pulls down, the first class lever, that pulls up, which lifts this pulley up. And it pulls another lever. That would be my fifth machine. It's another first class lever. And then my last machine is a inclined plane. Okay, so one of the things I want you to do is if you get a crazy machine or when you do your projects is you will go through and make sure your stuff's organized. So I'm going to find the IMA of each one because my total IMA is going to be all those multiplied together. So my first machine is pulley. I want to organize my work so if anyone looks at it, they'll be like, oh, here's where he did his work for the first machine. And IMA is hashtag strands. I want you to write the formula out, and then if I look at this, remember if I'm pulling down, I'm not counting that strand, so really there's two strands for your IMA. So I already got one of them. Boom, one down. My second machine is a wheel and axle. Right? So I moved to my second machine. And for wheel and axle, it's not strands, it's I'm a deer. Most formulas are I'm a deer, except for pulleys and screws. Okay, so when you think about this, where the power comes in, this would become your effort. And this would be your resistance. So my effort is going to be, effort distance is the 5, the resistance will be the 1. So 5 centimeters over 1 centimeter. Those cancel. You get 5. Cruising right along. Our third shape is a first class lever. And so lever, I'm a deer. So in this case, where's my effort? So the power was transferred through here, through here, through here. So my effort will be right there on the 4 centimeters. My resistance will be on the 2. So 4 centimeters, 2 centimeters. You get an IMA of 2. Then we move on to our fourth shape, which is another pulley, which is another IMA equals hashtag strands. Trending on Twitter. And on this one, be careful, because where's my power? My power is going up. So if it goes up, I count the strands. So 1, 2. So be careful on that. IMA is 2. Number 5 is another lever. So that's I'm a deer. And my effort is coming through here. So my effort's the 1 centimeter and my resistance is the 3. So I have 1/3. I'm just going to leave it like that. You could do 0.3 repeating if you want. And my last shape is an inclined plane. And that's I'm a deer. And on this one, DE, got to be careful on this. My effort is where I'm dragging the box, so 10 centimeters. My resistance is lifting the box 5 centimeters. So 10 centimeters, 5 centimeters is an IMA of 2. So now I have all my individual parts. See how it's organized and beautiful. So when I go over here to find my total IMA, IMA total, you're just going to multiply all those together. 2 times 5 times 2 times 2 times 1/3 times 2. None of them have units because they're all IMAs themselves. Right? And I multiply all that together and I get 26.6 repeating. Which means if this were your granny over here and she wanted to lift a box 5 centimeters into the air, which is not a lot, it would make it 26.6 times easier. So, that's helpful. Old granny can lift boxes now, right? Okay, so that's it for that one. That's what you have to do. You'll eventually have to do on your compound machine. Make sure you think of ideas on what you can build to assist someone. All right. Talk to you later.